All right. On that. All right.
I would say we need.
Thank you. Okay, so what we're going to do here, this is actually one of my favorite workshops, and after doing it a ton of times, I've also got some ideas of how you might want to. Once you see it, I've got some ideas of things you might want to do to make it a little bit more interesting as well. And just as a side note, this is one where I like the idea of not doing it in ES6 to start out with, because the issues that you're going to run into, if issues of context and binding and that sort of thing, it's good to sort of know how to solve these things. Not that if you're writing from scratch, you could write with ES6 and they won't be an issue, but there's high probability that you're going to be somewhere. There's going to be some code that's non-ES6, and you're going to have to understand it. So how does Game of Life work? So what happens here is that you have this scenario where the property of, you have this board and you have cells that are either dead or alive. Okay? Let's assume that if you're white, you're dead. If you're black, you're alive. Let's just actually see this one more time. So when the rule basically is fairly simplistic. And let me actually, sometimes I mix up what these rules are. And at some point, you will either flip from two different states, or you'll just be at one state, which is what you see here. And I'm not even sure that's actually the case. They just stopped the game there. So these are the rules for the Game of Life. You have these 2D grid of cells, and what happens is that your next state is determined by your current state. Right? Let me rephrase that. Your next state is determined by your current state and the current state of your neighbors. Okay? So what happens is that if you have a cell that's alive, if that cell will die, it'll basically starve if it has fewer than 2 live neighbors, right? So if it's either got no live neighbors or 1 live neighbor, it ends up dying. On the same token, if you have greater than 3 live neighbors, you end up dying because there's overcrowding. Okay? So that's the state for if you're alive. You're looking at your neighbors that are around you, and you'll determine what happens in the next state. If you're dead, the only way that you end up coming to life is if you have exactly 3 neighbors. So that's kind of what the logic is. It's fairly simple in terms of what your neighbors are. It depends on where you are on the board, which will determine your neighbors, right? I mean, if you are at the edge of a board, you might only have 3 neighbors. If you're in, you could sort of think about this, like if you're in this position on the edge, you're going to have 5 neighbors. If you're over here, you're going to have 3 neighbors. But otherwise, if you're not on an edge, right, you're going to have 8 neighbors. And you're going to have to look at what the states of those neighbors are to determine what happens next. The thing that's very critical here is that you basically determine the next state for each of the squares, but you don't change the state. You end up changing them all at the same time, right? So it's not like because you would end up getting screwed up if you started, it's the next step. Basically, you're stepping to the next state of the game. So, as an example here, if we look at this, right, if you're dead and you have exactly, 3 neighbors, you end up coming to life. So we can imagine that, who's got exactly 3 neighbors? I think.
Second, the one that's right there.
Okay, so this one here, right, but this is a cell that's alive, right? So here we could see this one here is going to die from overpopulation, right? So that one, oh shoot, hold on. So if we end up looking over here, black is alive, that's correct, right? So, I don't know, maybe I'm wrong about this, but let's see. Okay, so this gives us the, tells us, really wasn't all that helpful. You're basically looking at the next step. This is just playing a video to sort of see what happens. And so here, this is just showing you the progression of what it is, and it's pretty much just following the rules to determine, what happens with the next step. I always have to go back and look at the rules, even though I've done this 1,000 times, right? So, again, you're gonna die if you have, either one or no neighbors. You're going to die if you have 4 or more neighbors, right, greater than 3. And you're going to end up coming to life if you're dead and you have exactly 3 neighbors. So that's kind of what it ends up coming down to. Now, in terms of what the setup is for this, there's a repo that I have access to, although I think I'm going to have to make sure you could actually getting to see the workshop. I mean, really, this is, in terms of running this, I actually have this running right now. So all this stuff is set up for you. And this is the only thing that you can do here is this. Everything else you're going to have to wire up. If we take a look at this, some of this stuff you've seen already. So this is basically just dealing, this is all running client side. This is your index file. This is your table. And all those cells are being dynamically created. If we look at this game.js, you could see that we call game of life create and show board. And if we go up here, here is our create and show board. And what we're doing here is we're creating this element for the body. Here's our table HTML. And we've got our table. We basically set its inner HTML to these cells. Okay? And after that, we're going to have to set up all the events for the board. So what happens when you end up clicking on various elements on the board. So we've got that. Set up board events. And this is where, in fact, you see this first cell. We end up getting the element by ID of 0, 0. And again, that's a dynamically created element. You'll see that if we go up here, we're looping over the width and the height. And the ID that ends up getting set for this cell is going to be the width and the height. That's going to be why we have that 0, 0. And that's why this is the only one that's clickable. If I went down here and I ended up changing this to 1, 1. And reloaded this. Now, instead of this one being clickable, this one would be clickable. And your goal is to make sure that they're all clickable. A lot of the work, what you're doing is something we saw before, which is that you're going to have this function. Very often, what you're going to want to do for different reasons is iterate over all the cells. Okay? And so you're going to have this function which is going to iterate over your cells. The same thing that we ended up doing where we ended up creating that function that iterated over our DOM. This is a function where you pass it the iterator function, and you end up, what you expect to have happen is that iterator function will end up getting called with each of those cells. Okay? So again, if you want to do something on a cell, you could call this for each cell, pass in this callback function. That callback function will get called for all the cells that are on that board. And so you could, again, go through this process. It's an interesting thing to do. The thing that I always thought was cool, and I did this once, is that this is sort of set up as just sort of this static object. I thought it'd be kind of interesting if you had a constructor called Game of Life, and you could pass in, an ID for an element on the page. Then, theoretically, you could have, put in 5 or 6 Game of Lives and see them, take their course. It's something you could just give a little bit of thought about. At this point, you probably know enough about constructor functions. Once you get things working, you could think about how you would end up setting that up. I mean, I think what I would probably do is I would probably have something like, if I was creating a Game of Life, someone would pass me in a div on the page, and that's where I would auto-generate that Game of Life.
Does it explain what the point of one of these cells being clickable?
Yeah, because I mean, you can actually do it where they're not clickable, but I think what you want to do is that, you want to, when you're first setting this up, what you would end up doing is that, so for instance, if I just put this here and I clicked on step, I should see nothing on the page, right? Because it dies. But if I was to make these 3 alive, okay, and then I clicked on this, and I clicked on step, right? This would come alive, and basically the game would be sort of done. I could keep on clicking on step, and nothing would happen, right? I don't think anything else is coming alive after that. Maybe I'm wrong. Well, you'll find out.
Isolation.
What's that? This would die of isolation. That's exactly right. Okay? So again, once you end up being able to sort of step through it manually, then you could do something where you could basically say, hey, look, I want to run this game. I want to step at whatever speed you want, every second, every 250 milliseconds, or that sort of thing. At some point, you could build this where if you had enough cells that were on this thing and, you could really start seeing your browser start to degrade if there's enough stuff happening there, which is kind of interesting. And then you could think about, well, what could I do? In that case, you could actually think about, is there some way to sort of optimize this that might make a little bit of sense? But I would leave that. That's not really necessary for this. I would sort of leave this as an exercise. So let me